A hash table is used to implement associative arrays or mappings of key value pairs. Hash tables are a common way to implement the map data structure or objects. They are widely used because of how efficient they are. The average time for each lookup is not tied to the number of elements stored in the table. In fact, the average time complexity of hash tables in big notation is O of 1 for search, insert, and delete. That's very fast. The way a hash table works is that it takes a key input and then runs it through a hash function. A hash function basically just maps strings to numbers. And usually the numbers just correspond to indexes in an array. So for example, here are the strings. We pass through the hash function and then we get the numbers over here. A hash function needs to be consistent, so when you run a key through the hash function, it always gives the same number, and it should map different words to different numbers. If two words get hashed to the same number, this is called a collision. You can see in this example, John Smith gets hashed to 2, Lisa Smith gets hashed to 0, 1, Sam Doe 4, and then Sandra D also gets hashed to 2. So this is a collision because both of these names, once they run through the hash function, get turned into the same number or the same index for the array. One way to handle collisions is just to store both key value pairs at that index. Then, upon lookup of either, you would have to iterate through the bucket of items to find the key you are looking for. This could take a little extra time because of the iteration. So here's another example where it's showing that the names are going through the hash function, and then it's showing basically the information that's being stored in the bucket. So this would be the array index, and in that array index or the bucket we would store the phone number. So this would be like a phone book. The numerical value from the hash function is then used as the index to store that information. Then if you try to access the same key again, the hashing function will process the key and return the same numerical result, which will then be used to look up the associated value, which just means that once you store all these things in the array, once you want to get the number again, you would just pass in the key John Smith into the hash function. It would give you the exact same array index 2, and then you would get the information returned to you, which is the phone number. Now you'll probably never have to implement hash tables yourself because most languages, including JavaScript, already have them built in. In JavaScript, hash tables are usually used to implement objects. However, it can be helpful to see how they are implemented just to gain a better understanding. So I'm going to show you the code for a hash table so you can see how they work. First of all, we have our hash function where we're going to pass in the string that we want to hash and then the max. Max is the number of buckets that we're using in our hash table to store values. We're going to start with hash being 0, and we are going to, for each character in the string.length, for as long as the string is, we are going to add the char code of each character. Each string character has a numerical value associated with it, so basically we're just adding up the character codes for each character in the string and putting into the hash. Now, instead of returning the hash, we're going to return hash modulus max. That just means we are going to divide by the number of buckets and then return the remainder. So if we had 5 buckets, if we're dividing by 5, the remainder is either going to be 0, 1, 2, 3, or 4. And then that would be the index that we're going to place the item into the array. Now this is a very simple hash function, just for an example, but they can get much more complicated. Now let's go into the HashTable function. So in the HashTable function, we're going to have our storage array, which is where we're going to store all the data we're putting into it, and the storage limit. Now this is the number of buckets in the array. At first I'm just going to show you with just 4 different buckets, but normally actually this number will be much higher. And this is just a utility function just for this example, so I can easily print all the items in the storage array. I can easily log them. So here's where the real methods come in for the hash table if we want to add some information. So first you're going to pass in a key and a value. We're going to figure out the index of the array by running it through the hash function. So we created this hash function where we're going to pass in the key and the storage limit, the number of buckets that we're going to have in our hash table, and that's going to return an index that we went over before. If there's nothing in that index in the storage array, if it's undefined, we're just going to set that index to be this key value pair array. Else, if it's not undefined, that means there's already something in that bucket. So first we're going to set inserted to false, and then we're going to go through each index to see if the key already exists. If the key already exists, we're going to set the new value here and set insert to true. If the key does not exist, then insert is still going to be equal to false, so we're going to push in the new item. That's where we'll get multiple entries into one bucket. So the next thing is if we're going to remove an item from the hash table. So if we're going to remove, you just pass in the key of what you want to remove, and now we're going to look up the index by passing it into the hash function. If the index.length equals 1, that means there's only going to be one item in that bucket, and the item in that bucket equals the key that you passed in. Then you can just delete that index. You can just delete that item. But if it does not equal 1, that means there's probably a few different items at that index, and we want to only delete the item associated with that key. So we're going to go through each item in that bucket or in that index, and if the key equals the key we passed in, then we can delete that item. The 0 index is the key, the 1 index is the value. So let's go how we would look up an item. Again, we're going to set the index using our hash function with the key that we passed in and the storage limit. If the index there is undefined, we just return undefined. It's not, the item is not in the hash table. Else, we're going to go through each element in that bucket. If the element equals the key, then we can return that element. So let's look up a few examples. First, I'm going to show you an example of the hash function here. If we run that, it's going to be 3. And every time I run that, you'll see in the console 3, 3, 3. Every time I put bow, it's going to put 3. But if I put a different name here, and I run that, you can see on the console it's going to be 5. And now every time I run that, it's going to be 5. So with this hash function, it's going to always be a number between 0 and 9 because we're passing in 10 as the number of buckets. So now let's actually see the hash table. So here we're going to create a new hash table called HT for hash table. We're going to add Bo, who's a person, add Fido, who's a dog, Rex, who's a dinosaur, Tux, who's a penguin. Then we're going to look up tux, and then we're just going to print the entire thing. So let's see what happens in the console. So we saw that tux is a penguin. Now let me bring this over a little bit. It's going to show our entire hash table. Now normally you're never going to print out the hash table like I did to the console, but I just did that just for learning purposes. If you remember up here, we have the storage limit set at 4. So we only have 4 buckets. The reason why I had it set at 4 is so we will see what it looks like when there's a collision, when there's 2 things in one bucket. Just by coincidence, the first bucket is undefined. That means none of these words hashed to 0. And then if we look at the second bucket, that's right here. There's actually 2 key value pairs in the second bucket. So both bow and tux both gave 1 when it went through the hash function. And then you can see in this bucket right here, we just have 1 item. And in this bucket right here, we just have 1 item. So when we pass in rex to the hash function, we got 3 returned. But if we go up here and we change the number of buckets to something like 14, now I'm going to try running that again. If you look right here, now there's a lot more undefined because most of the buckets are now empty. But this bucket only has 1 item. That bucket has 1 item. And then the last 2 buckets have 1 item. And there are no collisions now. Each bucket only has 1 item. Now this has just been a pretty simple example of a hash table implementation. But it's enough to give you a basic idea of the hash table.